Good morning, good afternoon, good evening, wherever you are. Welcome to this presentation of neural network traceability. Can I have the next slide? Mihai, can you move the slides?
Sorry,
So this call is issued by MPI. MPI is Moving Picture Audio and Data Coding by Artificial Intelligence, an international, unaffiliated, non-profit organization based in Geneva. We have the mission of developing technical specification for coding, which means efficient representation of any type of data, technology that facilitate integrating of this component into complete systems, and importantly, bridging the gap between the specification and their practical use. We operate based on open international collaboration of interested parties who support the MPI mission and the means to accomplish the mission. In the next slide, you will see a quick overview of the standard. We have AI framework, we have a standard for audio, connected autonomous vehicle, prediction of company performance, gaming, governance of the entire ecosystem, how a human and machine can communicate, but deeper at the semantic level. And similarly for a multi-audio conversation, we have an important standard for the MPI metaverse model. Neural network traceability and neural network watermarking are two of the standards that we have already developed, and we wanted to add a third one. Then we have object and scene description, we have portable avatar, and we have profiles, and we have qualifiers. Qualifiers is a standard that enables the indication of the specific technology that are used in a particular application. With that, I move the presentation to Mihai, please.
okay, thank you. Let's see whether my camera will work. And now let's go a little bit more into detail related to NNW tech. First, let's set the landmarks. What is neural network today? Neural network today is a continuously new field, both from industry, academia, public organization. There is an effervescence, and the trend is always climbing. The deployment is in an increased variety of domains. We may say practically in the most, if not in all the domains of economic interest today. And we may find neural networks and AI built on the top of neural networks at the heart of various autonomous systems, from simple robots to unmanned vehicles. And sometimes such unmanned vehicles also have passengers. And I use this example just to draw your attention about how NN and AI can be deeply involved in critical application. Also consider medical decision making or critical industrial processes in hazardous industrial environments. This turns neural networks into a costly field. You want to produce yourself a new model, you want to buy an existing AI, you want to rent a pre-built model. All this action results in consequent cost. Moreover, AI usage became multifold. Complex AI solution could use multiple alternative neural networks to provide an inference. And identifying the specific neural networks that actually produce that inference, it's important. An AI can be also shared among multiple users, and keeping the track of this sharing process is useful. And also AI can be altered by errors or by malicious attacks. And we also need to identify such modification in order to avoid faulty functioning. These three examples and this brief introduction allows me to conclude that ensuring traceability and integrity of neural networks becomes mandatory. Neural network traceability enables, in the most general acceptation, the identification of the origin or verification of the integrity of data. Actually, it's more complex, and specifically in the field of neural networks, traceability should be understood as the possibility of tracking the distribution, the storage, the exchange, the use, or the evolution of neural network models. Specifically, MPAI studies two types of traceability method, watermarking, the active traceability techniques, and fingerprinting, the passive traceability technique. And I shall came just now with explanation on these active and passive words. First of all, watermarking as inherited from the multimedia relates to the insertion of some additional data of watermarks into an original content. And this insertion process should be imperceptible. So after the insertion, the neural network should ensure the same functional task with the same performance criteria and should be persistent. What means persistent or robust? That means that the inserted watermark should not be recovered only from the contents that actually has been watermarked, but also from all its modified replica. And just imagine you watermark a specific neural network, you should retrieve that watermark even when that model is fine-tuned or it's crowned or it's quantized or it's used in some federative learning setup and so on. The neural network watermarking, it's a field more complex than multimedia watermarking. It's no longer a static process in the sense that we no longer have let's say an original, a pristine content and its version after watermark insertion. This is because the most of current day method actually insert the mark in connection with the training process. It's a during training insertion. And hopefully that watermark will be able to be retrieved not only from the model in itself, but also from the inference produced by that model on feed with specific data. These changes makes the evaluation of the watermark impact of the imperceptibility operation a very complicated issue, both from conceptual and from practical point of view. Let's go now to fingerprints, and as we know from some 140 years already, if we take the tip of the fingers of a person, we are able to identify the identity of that person, no matter how this person change with age or with some disease and so on. So this word also applies to content, to multimedia content as perceptual fingerprinting, and in the specific case of the fingerprinting for neural networks, it relates to the procedure of extracting some binary information from the neural network model and from the ability of retrieving in a large database the model starting from this fingerprint. We speak now the uniqueness, so we have to be able to uniquely identify the models thanks to the fingerprint, and also to the robustness, much in the same sense as in watermarking, in the sense that the fingerprint should be able to identify the model in itself and all its replicas that do not severely impact the task. I mean, fine-tuning, pruning, again, the same example as I provided for watermark. So neural network watermarking tech inside MPAI considers watermarking and fingerprinting as traceability technologies. Our work was quite short in time if we consider the usual timeline for standard developments. We started in January 2022, and now 3 years and a half later, we already issued 2 standards as MPAI standard. One of them is also promoted as IEEE standard, and discussion with IEEE are ongoing for the second standard. We also have reference software for this specification, and the reference software, it's of various type, can be computer-oriented software as it can be embedded software. And now we just launched a new call for technology on NNW Tech. That is actually the purpose of this presentation. So what is the scope of a new standard? In order to better precise the scope, let me first define what an actor in MPAI NNW is. So we define an actor as a process that produces, provides, processes, or consumes information. So actor, it's a process for us. Of course, that process can always behave on behalf of a human, but by actor we understand some process running on a platform. So having that in mind, the target and the scope of the NNW tech, it's first to verify the data provided by an actor and received by another actor is not compromised. It's to identify the actors providing and receiving data, and it's to evaluate the quality of solution supporting that 2 points. Other way to make it shortly, this third point, don't forget the properties of imperceptibility, of persistence, of uniqueness, and of robustness I just spoke about before. MPAI is calling for NN traceability technology and technologies, and this call have several components. It is first composed of administrative and logistic data, presenting general submission, guidelines, and deadlines to be strictly observed to. Then we go on with 3 use cases that are, we call them generic use cases, that relates to the previous 2 points, first 2 points on the scope of the standard. So identifying the ownership of a neural network, identifying the neural network as any digital content, as it would be a DOI, and verify the integrity of a neural network. We also have functional requirements, and we list a set of requirements that the process technology should satisfy, and you have the complete list in the document. There is also the framework license and the template for responses. As maybe the previous 3 use cases seems quite abstract, we outline here 3 application scenario just as illustration, just as example on how these 3 generic use case can be articulated together in order to serve more complex applicative workflow. First of these three examples is called traceable newsletter, and assume the case of an user who subscribe to a service. It's a generative AI which periodically produces a newsletter that it's customized to the user profile, to what that user explicitly express, or even from its user profile extracted by the neural networks analyzing its behavior. Now, this newsletter can be intercepted and maliciously modified into a realistic yet fake newsletter. So we need that generic use case 3. We need that for the end user to ensure about the authenticity of the newsletter. So we can say that the simplest usage here is that when the user receives its newsletter, just verify the authenticity of the content. If it's authentified, read it. If not, that content can even be blocked by a process running on its email and so on. We can also imagine the facts that based on the second generic use case, a famous brand community manager, a goodwill actor, identify the neural network, the original neural network, inform about the fact that the newsletter was maliciously modified, and directly or indirectly correct and comes back to the original newsletter that can be hopefully delivered to the user. Other use cases we studied related to the traceability of neural networks and of their inferences. It's more critical, if I can say that, and relates to autonomous vehicle. So today, an autonomous vehicle, we represented here the case of terrestrial unmanned autonomous vehicle, but the concept is general. So such vehicle, it navigates thanks to the collaboration between among a network of distributed AI. Some of them are embedded in the car, another of them are closer or farther to the network. So the leader emission reception signals became input to an AI, and as a general trend that AI should continue learn, it's an evolutive AI, can be embedded directly in the car or can be deployed remotely. But as this AI modifies itself in order to better navigate the vehicle, how can we know that it was not maliciously modified? So here again, we have in this complex use case representation on how the three generic use case can be combined together. First of all, thanks to ownership verification, a remote server, a cloud server, can decide whether to process or not the data. The signal exchange between two autonomous vehicles in the same area can be authenticated thanks to the generic use case 2, while the fact that an already deployed evolving AI was not maliciously modified can be verified according to the generic use case 3. The third use case, the third applicative scenario, is the generative AI deepfake. And we don't speak here about a deepfake, malicious deepfake. We speak here about a user who dreamed to be a superhero and who takes a selfie and who subscribe to a generative AI deployed somewhere in the cloud. And so this generative AI service just receive the video stream or the selfie taken by the end user, and according to its capabilities, modifies that content for transforming the user into a superhero. So here again, a lot of distributed AI. Each smartphone today considers AI in its very camera. So we have some AIs that can be attacked even at the level of the device. The compress stream can be intercepted and modified. The generative AI solution can be modified again, and the output of that AI, the stream or the graphic content that is to be displayed on the screen can be again modified. For such a use case, the generic use case too, so identifying the NN in order to be sure from whom the content provides, and checking the NN integrity are the most important to be ensured. So after seeing these use cases, let's go to the requirements. So an actor, as defined previously, is that process abstract type of processes that it's involved in neural network exchange, storage, evolution, or processing, should be able to detect whether a content, and we speak about the content in the sense that can be the model or inference that model produces, includes the tracking technology, to detect whether the source data had been processed during the transmission from the source to the sink by applying a tracking technology, to decide whether the data preserves the syntax and the semantics of the source data when transmitting data, including a tracking technology, and to decide whether the data preserve the syntax and semantics of the source data when receiving data, include a tracking technology. Additional requirements are also listed in the corresponding documents that is mentioned in our call for technology. So a watermarking technology to source data should be able to retrieve the payload from the neural network or the neural network inference in order to allow the identification of the sender and or of the receiver, to verify whether the data was sent by the intended sender, to verify whether the data was meant for the intended receiver, and to verify whether the data was received by the intended receiver. For the fingerprinting technology, the requirements are fewer, in the sense that the fingerprinting technology to source data should be able to identify the neural network or its inference. So, Leonardo, if you want to take this one for the framework license, please.
Sure. So there is an important complement in the call for technologies. This is what we regularly do for all our calls, and we had quite a few now, is the notion of framework license. What is a framework license? It's a process, I mean, the result of a process that starts when we are at a stage like in this project, before we are initiating the development of a standard. The principal members that are active in a particular area develop and adopt a framework license. In spite of its name, a framework license is not a license. But it is a license where we don't have values, we don't have dollars, we don't have percentage, we don't have dates, we don't have this kind of data. And it also declares that the eventual license, which is different from the framework license, because the framework license is not a license, and of course, MPI will have no say in the eventual license, will be issued at a price comparable with similar standard technologies, and not after products are on the market. So this is the first point. The next point, during the development, any member making a submission, a contribution to further develop the standard, it declares that it will make its license available according to the framework license. And finally, after the development, and this is the last step where MPI has anything, well, MPI in terms of its members, of course, not MPI as an organization. After the development, the members holding IP in the standard select the preferred patent pool administrator. So that is what is behind this words framework license. Next slide. So for those interested in submitting, so we have important dates, a few, let me present them. The call has been issued, that was at the last General Assembly. Today we have the online presentation. If you are interested in making a submission, you are invited to, it's a very simple form where you notify the Secretary of the Internet to submit. With a note that if you don't submit, we will still accept your submission. If you send a notification but you don't submit, that will be the end of the story for you. The submission deadline is the 27th of September, and the evaluation of responses starts at the 68th General Assembly. By the way, that will be the 5th anniversary of the MPI establishment on the 30th of November. You have an address here, an email address, which is where you should submit your proposal. With that, I thank Carl for proposing this Submit Innovation, Inspire Transformation. It's an excellent logo, thank you. And here you have the text of the document. There are 4 documents: the call for technologies, use cases and functional requirements, which is essentially what Mihai has presented, the framework license, which is what I have last introduced, and there is a template that you are invited to use, because we are quite finicky about receiving certain statements that are important to guarantee that the process performs correctly. And as you see, there's an invitation to join MPI. So this is the other logo, which is share the fun and build the future. And with that, I close this presentation. I invite Jacopo to stop the recording, and